Hello everyone, welcome back to another video on the Education Always channel. Today we will be looking at the periodic table. In this video we will cover Mendeleev's periodic table, pair reversals and the modern periodic table. Before discovering protons, neutrons and electrons, scientists tried to classify the elements by arranging them in order of their atomic weights. The atomic weight of an element is equivalent to what we now call its relative atomic mass. Early periodic tables were incomplete since many elements were unknown. Also, some elements were placed in groups with elements that were not similar to them. Dmitry Mendeleev was a Russian chemist. He wrote chemistry books and was looking for ways to organize the known elements. He published his first periodic table of the elements in 1869. In it, he arranged the elements in order of increasing atomic weights. He also took into account the properties of the elements and their compounds. This meant that his table had gaps in it and showed elements with similar chemical properties lined up in groups. However, from their atomic weights, some pairs of elements next to each other were in the wrong order. Mendeleev left gaps in his table for elements not known at the time. By looking at the properties of the elements next to a gap, he could also predict the properties of these undiscovered elements. For example, Mendeleev predicted the existence of EKA silicon, which would fit into a gap below silicon. Another scientist later discovered the missing element germanium. Its properties were found to be similar to the predicted ones and confirmed in Mendeleev's periodic table. On the screen is an example of Mendeleev's periodic table. Iodine has a lower atomic weight than tellurium, so iodine should be placed before tellurium in Mendeleev's periodic table. However, iodine has similar chemical properties to chlorine and bromine. To make iodine line up with chlorine and bromine in his table, Mendeleev swapped the positions of iodine and tellurium. Mendeleev did not know about isotopes, but their existence explains pair reversals. The positions of iodine and tellurium were reversed in Mendeleev's table because iodine has one naturally occurring isotope, iodine-127. The most abundant tellurium isotopes are tellurium-128 and tellurium-130. The high relative abundance of these tellurium isotopes gives tellurium the greater relative atomic mass. The atomic number of tellurium is 52 and the atomic number of iodine is 53. These elements are in the correct order in the modern periodic table. In the modern periodic table, elements are arranged in rows called periods in order of increasing atomic number. Elements with similar properties are placed in vertical columns called groups. The table is called the periodic table because elements with similar properties occur at regular intervals. On the screen is an example of the modern periodic table. And that's it for today. Thank you everybody so much for watching. Please don't forget to like and subscribe for more, and any questions, pop them down below in the comments. Thank you, bye!